All right, welcome back. I'm Thomas Paul, 10 plus years tutoring math and science and unlocking student potential. And we have another trick today, a classic time waster from the SATs. It's a diagram, a lot of words, and some information that we need to parse through really quickly. So let's take a look. It says in the shower, there's a triangular shelf system composed of 3 parallel shelves. What's the maximum height in inches of a conditioner bottle that can stand upright on the middle shelf? So we always start with the background. What do we need to solve this? And I think one of the most important things to begin doing is to write on the triangle immediately. So the given values, the givens, what's given to us? Well, let's look at what's given to it. We have the parallel shelves. So we mark the parallel shelves here. I've marked them previously. And we're also going to notice something. Let's just mark this though on this one first. So we have parallel, parallel, parallel. So if we look here then, if we look at this corresponding angles, this angle then should be equal to that angle because of the corresponding angle theorem. So now we see a bunch of angles there. And you see, when we write our givens on there, we write from the parallel lines, we can begin to see, these are going to be all similar triangles. But more on that in just a minute. First, what else do we have to put in there? It says here we want to know the maximum height in inches of the conditioner bottle on the middle shelf. So it looks like we have 3 different heights. So let's give them letters. This can be hard at first, but you have to be confident. Let's call this the top, T. Let's call this the middle, M. And let's call this bottom one just B, bottom. So, and this brings us to the next part of the background. We need to set up equation. You see EQN for these values, for height in this case. So we know here that T plus M plus B, that's going to give us 18 inches. So that's one equation we can use right away, and it gives us confidence that we're progressing towards our value that we want, which is M. In fact, we can even solve for it if we want to. M we know is going to be 18 minus T minus B, if we ever get that far. Let's see if we'll get that far. Now let's go to the third bit of background, or step we need to progress to. And this is something that's not really seen much in the high school classroom. We need to set up intra ratios between the similar triangles. And let's show that they're similar here. So if let's take each of these triangles down and break them, because actually we have 3 different triangles here. Let's first draw the big one. We have x plus 3x and 2x. That gives us a total side length here. If we draw this bigger triangle here, that's 6x here. And we know this height happens to be 18. But wait, we also have the next, we have a slightly smaller triangle with 5x, 3x plus 2x. Let's draw that almost as big, not to scale of course. That's 5x, and this is going to be, what's the height though? That's T plus M. I'll write that there. And finally, we got a last triangle, that's 2x. Not drawn the scale of course. That's T. And here's where these intra ratios, but before we get there, let's just show that they're similar. They all share the same vertex angle. And they all have the same corresponding angle here. So they're all similar by AA, in case we want to prove that later. Let's go to orange now. So now we're finally going to do these intra ratios. Well, we know that 6x, this side here, compared to 18, that's a ratio we can have it here. That's going to hold the same for all of these. That's going to be like true of 5x. It's going to be equal to T plus M. And we know that 2x will be in ratio, probably not equal to, but in a ratio to T plus M, and 2x is in ratio to T. Well, then what's the ratio truly about? If we divide both sides by 6 here, we know that for every x of this diagonal length, we should expect 3 of height in all these similar triangles. Well, how many x do we have here? That's just here, we should expect that in this case, if we have 5x, that we should be generating 3 height for every 5x, we should be 15 here. And that means that 15 equals t plus m. And then finally, we have another equation we have here. This is the 2x. Well, it's the 2x says that we should have 6 for height. That means that t is 6. And now we have enough equations. T equals 6. Well then here, we can plug that back into this equation. Because we know that 15 equals t plus m. Well, if t is 6, so 15 equals 6 plus m. And look, our unknown is now solvable. Subtract 6 from both sides. And we get that m is equal to 9, or 15 minus 6. It's the answer there for the height. So what was the trick? One, it was meant to waste time. So the first thing you'll do on the SAT is write these givens and immediately draw on it. Set up this equation, or if you like, you can immediately progress to drawing your intraratios. This is something that you don't commonly see in high school, so it's something you want to practice here and begin to know that if all the triangles are similar, the ratio of a diagonal side length to the height of one triangle must be the same in all the similars. And that's the key. You end up with a height of 9 inches on the middle one. Until next time.